In this video, we're going to talk about the graph of a function. Graphs come from data, whether it is collected data over a period of time. So for example, what we're looking at is the average retail price of gasoline in $2008 from 1980 to 2010. So that's just a data set, and it's modeled by this lovely graph here. Or it can be modeled by a function or a relation in which it has an infinite data set. So I want you to think about data and graphs as essentially the same thing. It's just a different visual that we're looking at. So while graphs are visual representations of a data set or a function or a relation, there is a lovely thing called the vertical line test, which I'm sure you've heard of and used before, but here to remind you that the vertical line test tells us from the graph if the graph is a function or not. So it is what the name suggests. You would draw infinite vertical lines, or a handful to prove your point. And if the vertical line crosses 0 or 1 points of the graph, it's a function. But if it crosses more than 1, so 2 plus, not a function. So for example, this parabola, we know that's a function because it's only ever going to cross any vertical line once. This cubic function, also, it's a function. I just gave that away. It passes the vertical line test. This, what we'll call a sideways parabola, not a function, because looky here, almost every single vertical line you could draw crosses it in 2 places, so not a function. It's a relation, not a function. And then this circle, we've learned very recently that circles are not functions because they do not pass the vertical line test, much like this sideways parabola. So, vertical line test, very useful. So now let's talk about what a graph can do for you. And it's a lot. You can get a tremendous amount of information from a graph. So let's take a look at this example of a trigonometric graph. This is a sinusoidal curve, which we will cover much later. And we're going to read some information from the graph. So let's start off first with this question, which is what are f of 0, f of 3 pi over 2, and f of 3 pi? Remember, anything after an f or g or whatever is an x value. So I will be looking for where x is 0, x is 3 pi over 2, and x is 3 pi. So when I'm looking for f of 0, I find where x is 0 along the x-axis, and I go boop all the way up, and I find whatever the output is, or whatever the y value is, or whatever the height is. However you want to figure it out, all those words are great. So this is how we would express it. F of 0 is equal to 4. And I'm going to do the same thing looking for where x is 3 pi over 2, and I found the output to be 0, so that's going to equal 0. And for x is equal to 3 pi, I'm going to get negative 4. The next 2 pieces of data that I can pull from this graph are its domain and its range. So first I want to look at the graph and determine if this thing goes infinitely in either direction on the x or y axis. So when looking for the domain and range, it's important if I have infinity involved. But I don't here, and here's why. On my domain, which is my x-axis here, I have these points, and I have to take the graph at face value. I can't be like, well, maybe it goes on, or maybe it doesn't. I don't know. You got to take the graph for what you have, which tells me there aren't any arrows coming off of this point or that point, so it goes from x equals 0 to x equals 4 pi. So when I write the domain, I can either choose set builder or interval notation. So that's going to go from my x values from 0, including 0, all the way to 4 pi, including 4 pi. So that's how that is expressed in set builder. And I would use brackets on both the 0 and 4 pi in interval notation. Quick note here, always look for just the x values. It's very easy to get tripped up and write an x and a y, like a coordinate, especially an interval. Just make sure either you like highlight or circle any of that if you feel like you're going to get easily confused between the x and the y coordinates. Speaking of y coordinates, let's talk about the range. So I always look as if it's the number line, but I kind of, if you want to cock your head to the side a little bit and go this way from like technically this left to this right. So I'm looking at the lowest point or the smallest number that the y values dip down to. So that looks like it's -4. It doesn't matter how many times it dips down there. It looks like the lowest point is -4. And what's the highest point on the y-axis looks to be +4. And I can express the range in set builder or interval notation. So please keep in mind that we're talking about range, so that's y. So y here, y there, and y there. But it's similar in terms of using the same less than, equal to, and the same brackets here for our -4 and +4. Even more wonderful information we can pull from a graph are their intercepts. Now, don't forget that if you have two axes, you can have two different kinds of intercepts, x-intercepts and y-intercepts. I know I'm telling you things you already know. So let's just find the coordinates of all the intercepts. All right, so I've gone through and circled them all in green, and I just happen to label the y-intercept 0, 4, and then all of my x-intercepts. So just a reminder that if you are looking, especially algebraically for y-intercepts, you'll set the x equal to 0, and vice versa. If you're looking for x-intercept, you set the y equal to 0. Y'all, there's even more stuff we can find from a graph. Wow, it's like it's a great resource or something. Wow. All kidding aside, what we can do here in these three parts is essentially look for different x or y values for whatever reason. So for example, if we were looking at that like gasoline graph, we could look for a certain year, which is on the x-axis, or we can look for a certain price, which was on the y-axis. So this is no different. All right, so part E says how many times does the line y equals 2 intersect the graph? So I'm going to crappily put a y equals 2 line on here. So it's not a totally crappy line because I didn't draw it myself. But this purple line is y equals 2, and it looks to cross our function 1, 2, 3, 4 times. So part F asks to find what values of x does f of x equal -4. If you forgot, f of x is like saying y. So what are the x values when y equals -4? So you could draw another line, or I actually just looked down to where y equals -4, and it looks like there are already two pre-labeled points there, which I love. And those are the only 2 points that get down as low as -4. So that means that x is going to equal pi and 3 pi. So, part G. For what values of x is f of x greater than 0? So remember, f of x is the same as y. So where is y greater than 0? So it's going to be intervals because if I think about this x-axis, right, y is negative down here, but y is positive or greater than 0 up here. So it's going to be this little piece, this little loop, and that little guy. So let's write that out in interval notation. So starting at x is equal to 0, because it's way above 0 on the y-axis. So starting at x equals 0, including x equals 0, it's going to go all the way to pi over 2, but it's not going to include it because y has to be greater than 0, not equal to. So that's a parenthesis. Skip over this little chunk, start at 3 pi over 2, parentheses, go all the way to 5 pi over 2, parentheses, and then start at 7 pi over 2, and then go all the way up to 4 pi, which is right there. Luckily that's labeled for us, but another way to figure this out is figure out what the x-axis is counting by, and it's by a half of pi. So 1, 2, 3, 4, 5, 6, 7, 8. 8 halves is 4 pi, or you could just read the graph. Now let's move on to an example where we don't have the graph. So I'm going to resist the urge to graph this, but let's consider the function f of x is equal to x plus 1 all over x plus 2. So let's find a few pieces of information from this, and then let's graph it and see if we did it correctly. So the first thing I'm being asked to do is find the domain. So if you remember, the domain of most functions is all real numbers, except for wherever it's restricted. So remember that is if you have a variable in the denominator, of a fraction, or if you have a radical. That is an even root. So square root, fourth root, sixth root, etc. I don't have a radical, but I have a variable in my denominator. My first step is to set that denominator not equal to 0. You could set it equal to 0, it doesn't matter. And I find that x cannot be -2. So in terms of a number line, if you like to visualize that, it's an open circle and -2, and then you shade to the left and shade to the right. So it's all real numbers except -2. So in interval notation, here we go. And then in set builder, here we go. Whatever floats your boat. And so moving on to these next two things, I'm asked to find is point 1, 1/2 on the graph of f. So again, without graphing it, what you can do is you can plug in either the x value, so 1 in for x, or 1/2 in for f of x or y, and see if it equals the other number. Personally, I like plugging in x, so let's just do that. So when I plug in 1, so f of 1, I get 1 plus 1 over 1 plus 2, which is 2/3. And is 2/3 1/2? Nope. So 1, 1/2 is not on this graph. And moving on to part C, if x equals 2, what is f of x? So that means that I'm going to plug in 2 for x, much like how I plugged in 1 here. And then what is the point on the graph? That just means write it as a coordinate pair. Thankfully, these are some pretty nice numbers. So 2 plus 1 over 2 plus 2 is 3/4, so 2, 3/4 is on the graph of this function. So we're going to take that last question and flip it a little bit. So if f of x equals 2, that means if y equals 2, if my output is 2, what is x? So I'm solving for x and not y here. And then what's the point on that graph? So what I'm going to do is I'm going to set f of x equal to 2, and I'll show you how I do that. Obviously, I'm going to show you how to do that. So I've set up my equation here, and I've got my x plus 1 over x plus 2, which is a fraction. And I need to set that equal to 2. So I also want to make that a fraction because I am really partial to cross multiplying. So that's what I'm going to do here. Is that the only way to solve this problem? No, but that's what I prefer. So you can do whatever you like. So when I do that, I'm going to do 2 times x plus 2 and 1 times x plus 1, and then distribute the 2, yada yada. And then I prefer to move my x over here and my 4 over here, so subtract x from both sides, subtract 4 from both sides, and I get x is equal to -3. So that tells me there's only one point on my graph that y equals 2, which is great. So that coordinate pair is going to be -3, 2. And so the last thing that we're going to be asked to do in this video is find the x-intercepts of the graph of f, if there are any, because there are some graphs that don't cross the x-axis. So remember, x-intercepts means that I set y equal to 0. So I'm going to do that and see if I get anything. So I'm going to use the same process as the last example and cross multiply. So I end up with 0 is equal to x plus 1. So that means that x is equal to -1. So there's one x-intercept at -1, 0. So, of course, I'm going to do the thing that I said that I wouldn't do, and that is graph the function, because I just can't help myself. Plus, I like a good visual. If you're like me, graph your functions. So, what it tells me is that I do have only one x-intercept, and I do have a break in my domain at x equals -2. And then these are the other 3 points that we were asked to find from the different parts of that question. So, could we have graphed it at first and found this information? Totally! But you should also be equipped to find these things algebraically, just in case, for whatever reason, you are unable to graph these functions. That's going to do it for this video. Thank you so darn much for watching. I'm sorry.